Welcome to NXCAM 20-minute tech tips. Today's session is on how to fully control your tool paths using generic motion. The demo will last approximately 20 minutes, and then we'll stay on the line and open up a chat window for Q&A. With that, I'd like to turn the session over to John Chaplin, who's going to be doing our demonstration today. John, welcome.
Thanks, Aaron. I'm setting up my desktop here. Can everybody see me okay?
Let's see. Yep, we can see you just fine.
Great, great. Okay, this will be a brief demonstration on using generic motion for creating drilling and milling operations. Generic motion can be used for a few other types of things. It's been used for probing, that sort of thing. But let's take a look at, here I have a part sitting on a machine, and we might want to do something like some deck drilling of some spaced holes. Generic motion would be great for an operation like that. To create a generic motion operation, it's available when you choose insert operation, and when your type is mill multi-axis, we can go ahead and create a generic motion operation. We're going to be doing this using a drilling tool. The geometry parent is normally workpiece, and method is usually left at method. We'll be fine here. And I can go ahead and choose OK to create a generic motion operation. Now, a generic motion operation is an operation that consists of a lot of little sub-operations. When I choose Add New Sub-Operation, as you can see, I get quite a few choices. I can linear move to a point, linear move along a vector, linear move along a tool axis, and a lot of these other choices. We can insert machine control commands, so I could bring the cutter to a point near the part and do something like turn on the coolant. So there's quite a few options to drive your tool. One of the options that I like to use the most is this rotary point vector move. I think you'll see that it's very flexible and user-friendly. So what I want to start with here is creating a rotary point vector move. Now, the first thing I probably want to do is present the tool near the part so that we wrap it up close to the part. So I'm going to say our motion type is going to be a rapid motion. And the point that I want to go to is, I'm going to pick a point on the model, and then I'll just back it off a little bit in the X direction, a little bit in the Y direction, and lift it up a little bit in the Z direction, and choose Apply. It gets me there. Now that I'm near the part, I might want to approach this hole, and I can approach the hole at the approach feed rate or at the rapid feed rate. We'll say let's go to the approach feed rate, and the point that I want to go to is going to be the arc center of that. Now, if you wanted to back up a little bit off the hole, you can just drag the tool up the Z-axis. I'll drag it up about 50 thousandths, so we're about 50 thousandths over the top of that hole. If you wanted to go to an exact and an associative value, you'd use the point constructor. You'd go to the point dialog, and you'd open up rectangular offset, select the point, and then that point would be associative. Or you could create the associative points ahead of time, would be another option. We're just going to use locations on the model. And so now that I've got the tool at that point, I want to do another rotary point vector move. What I can do is say, in this case, I just want to visually drag it to the depth, but at this point we're going to go to the cut feed rate, and I'm going to say let's go about that deep, and choose Apply. Now we want to go at a traversal feed rate because we're cutting air, so I'll say at the traversal feed rate, the next point that I want to go to is, I'll pick that arc, and I'll say let's go about 50 thousandths back from that point. Choose Apply. Now we'll be back to the cut feed rate, and I'll say let's simply go to about that deep, and choose Apply. Now to pull the drill out of the hole, I'll just say let's do another, and we'll do this at the retract feed rate. I'll say the point that I want to retract to is the arc center of that, and we'll back it up about 100 thousandths over the part. At the traversal feed rate, I'll go over to the next point, and again about 100 thousandths over the part. And now we're going to be drilling again, so I'll go with the cut feed rate to a point of about that deep. Apply at the traversal feed rate to a point of about here. So you can see this is pretty quick. Actually, I'll pick the, we'll call that good and choose apply, and then I'll say our next point is going to be at the cut feed rate to a depth of about here. So you can see it's very user-friendly to be able to drive your tool this way. And finally, we'll pull that drill out of there because what I'll do is I'll do a, at the retract feed rate, we'll just go to a point up about there, hit apply, and then we want to get the tool away from the part so that we have a safe retract. So I'll just say our next motion is going to be up there and over there. And choose apply, and that's about it. Now I can go ahead and generate that operation, and when we verify it, we'll verify it with machine simulation. If I right click, I can choose tool path simulate. It brings up the simulation control panel, and of course what I'd like to do is a machine code, a G code simulate, because that's what we're actually going to be sending to the machine. So I'll say give me a machine code simulate. One of the nice features when we're doing the machine code simulate, we'll see the rotary table move and everything. We'll see that actually in the next operation. But we'll also see a simulation of the feed rates. If I go ahead and slow this down and play it forward. So it's happening as the tool is approaching the part there. Now if you watch the feed rates, the simulated feed rates, so it's going pretty fast, it slows down, speeds up, slows down, comes out pretty quick. You'll actually see the slowdown when you're doing the cutting and the speed up when you're doing the traversals. It's not at the actual feed rates per time and distance that you're seeing that happen, but it's at a relative, so you can see when you're going faster or slower there with a relative speed replay, which is kind of nice. So that would be a use of a drilling tool in a deck drilling situation like that. Could come in very handy. There's been a few enhancements in NX8 generic motion where you can actually follow edges and machine surfaces with it. We'll do that with another operation. Maybe I want to bring a tool in and machine this face of this pocketed shaped area in the part. Generic motion can work fine for that. I'll choose insert operation. Actually, let me shut off. Before I do that, I'm going to shut off the machine. It will be distracting if we see the machine, because the machine simulation will come in after the fact. And now I'll choose insert operation, and I'll say give me a generic motion operation, this time using an end mill. We're going to create some sub-operations, so I'll choose add new sub-operation. Again, I like those rotary point vector moves. I can simply pick a point near the part that I want to go to and then set my location. What we're going to do is present the tool near the part. We want to leave plenty of room for the rotary table to be able to rotate. So we're getting the tool kind of close to the part. And then to rotate the rotary table, what we can actually do is rotate the tool. If I rotate the tool to 90 degrees, you'll see the effect of that when we go ahead to simulate that. And I'll pull the tool out about over here. And that'll be kind of an approach motion to our cutting. Now with another rotary point vector move, what I want to do is get the tool closer to the part. So I'll say the point that I want to go to is that point on the part. Lift it up a little bit and out there. So we're going to do a few points in approaching the part. Now that I'm kind of close to the part, I'll say let's do another rotary point vector move to there and just move it off in the X direction. We're at the right height. All of this has been at the traversal feed rate. I could shift it over to the rapid feed rate, would be fine. Either depends on how you have your feed rate set up. Then finally, what I want to do is I want to machine those edges so I can use follow curve edge sub-operation. Our selection toolbar is available, our curve rule toolbar, and the curve rule in this case is going to be just tangent curves. I can say the tangent curves that I want to follow are and select that curve. It selects all the tangent curves, and choose OK. So now we've just machined that surface as we're going to see, but I want to end up by also pulling the tool off of the part, so I'll say let's add another new sub-operation, another one of those rotary point vector moves. I'll say the point that I want to go to in this case is just off the part a little bit. Apply, lift the tool up to get it away from the part safely. We'll drag it up the Z and maybe over here on the X and choose apply, and that should about do it. We've just programmed the 4-axis operation. And I'll turn the machine on and we'll simulate that. If I go to the operation navigator, I might want to generate that generic motion operation. And then again, go to toolpath, simulate. And we want to simulate the G code, the machine code, so that we'll actually see the rotary table move and everything, and play that forward. And in comes the tool. I've got a couple of safe approach points there so that we don't wrap it up to the part too closely while the rotary table's turning. So we're coming into position. All these points can be edited as well. Perhaps I'd go back and edit that last point. We dropped down a little much on the Z. That's all editable. And now we are machining that surface using the cut feed rate. And I can speed that up a bit. And that is pretty much some of the basic things that you can do with generic motion. It's a very easy to use tool, and in a lot of situations it's just a tool that'll get you there, get it done quickly, and that is the demo.